All right, last section we have for trig for now. We'll get a little bit more when we move on into chapters 6 and 7. Inverse trigonometry, inverse trig functions. All right, so these are going to be a little bit weird. We are going to skip some problems in the middle, so you're just going to do 1 through 37 and then 45 through 81. Still every other odd, you don't have to do all those. That'd be kind of crazy. All right, so here, before I get to what I have written over here, here is the problem with trig functions. Okay, it's really their inverses. The inverse is the problem. The problem is this. If you think about the graph of sine or cosine, what do? They do this. They go up and down and up and down and up and down, and they're very fun. They're very exciting, but their inverses don't work very well because they fail that horizontal line test. Really bad, right? I mean, any horizontal line you draw through them is going to cross them a lot of times. So we have to put some pretty serious restrictions in. And so that's what we're going to look at some of that over here. And it'll cause a few small issues when we get into trying to figure out inverse values and solve equations. But equations aren't today. Equations are for another section. All right, so let's look at sine inverse and cosine inverse first. First thing I want to point out is they have the same domain. Okay, that's why I put the domain here for them in the middle. It's from -1 to +1. The reason is very simple. If you think about your sine and cosine graphs, what do they go back and forth between? They go from -1 to +1. Those are the only possible values you can get out of a sine or a cosine function, anything between -1 and +1. That means when you do the inverse, now we're switching those coordinates, x and y's, so all of our inputs now can only be between -1 and +1. Okay, you cannot take the sine inverse of 7. If you try that, type it in your calculator. It won't work. It'll tell you it's undefined. The range. Okay, unfortunately, they have different ranges. So the idea here is we're trying to get all the y values that we need. Okay? And not have the repetition. So if you think about the original sine graph, it starts at the origin. When we come backwards, we're actually going to send our values back to -2 to -pi/2 to +pi/2. That way we get the entire graph from -1 to +1 without any extra repetition. So you're going to get some you're going to get some negative values out. Here's a hint: if you want it to be positive, if you get -pi/4, just add 2 pi, and that'll swing it all the way. That'll swing it around the circle and make it a positive value. For cosine, its range is going to be from 0 to pi. And again, that's because if you think of the cosine curve, it starts up at 1 and then goes down to -1. And it does that starting at 0 and it finishes going down to -1 at pi. For tangent inverse, tangent will spit out every real number there is. So when you do its inverse, you can plug in anything you want. But tangent is restricted in where it goes. Its range is only going to be from -pi/2 to +pi/2. All right, so that's kind of the basics, and we'll get some more here in just a second. All right, so here are a couple of problems that we're going to do with some inverses, some basic inverses. We want exact values for the sine inverse of a half. You'll notice I already have the answer there, so you'll have to just hold on and see how I get it. And then tangent inverse of the square root of 3. I have the answer down here. So here's the idea. Remember, we're working with inverses. So when we work with inverses, we have to think, what was the original input for a sine function or a tangent function? The original input was an angle. And so when we do inverses, that's what's going to come out of our inverses. So we're trying to find the angles. So for sine inverse of a half, what we're looking for here is the angle that will give us a sine value of a half. Now, you'll notice that I've got part of this quarter circle drawn down here. I've labeled the angles that we actually need for these two problems. And the idea is simple. Sine, remember, was a y coordinate on our unit circle. And so all we have to do is find where we get that y coordinate of a half and the angle that goes with it. In this case, pi/6. Or I suppose 30 degrees. Now I suppose you could cheat the system a little bit. You could put it in your calculator with degrees, and it would spit something out. It would, it would spit out 30 degrees. You could do sine inverse. By the way, on your calculator, this is that button right up above the sine or cosine or tangent. Those are the inverse functions. Okay, that little negative one just means inverse. All right. Anyway, so since sine is a y value, the angle that goes with it is pi over 6, or 30 degrees. And again, it kind of depends a little bit on the circumstances and what we're trying to do with it. All right, so that's sine inverse of a half. That's an easy one. Tangent is a messy one because remember, tangent is unfortunately y over x when we're working with our circle. And so it's more complicated. You can't just go, hey, I know which one it is just by looking at it. Or maybe you can. So it turns out it actually is going to be the pi over 3. And we can see that because it is y divided by x. So I took this ordered pair and I did my division here. Now, honestly, you might choose the wrong one. Most likely you would choose this one if you choose the wrong one. And if you do it, it won't come out to be the square root of 3. But if you take this one and do the y over x, remember when you divide by a fraction, same as multiplying by a reciprocal, the 2's cancel and you just get the square root of 3. So the tangent inverse of the square root of 3 is pi over 3. And so those are two pretty basic examples, and we're going to look at some little bit more complicated stuff here next.